Today we're working on the review for chapter 15 and 16. Questions 1 through 4 say to rewrite the logarithmic equation into exponential form. And so I'm going to take each one of these and rewrite them without a log. Remember that logs equal exponents. So this one would be 2 to the 5th power is equal to 32. The number that comes after the equal sign over here, that's the exponent. The base of your log stays the base of the this equation here when you rewrite it in exponential form, and then the number that's here, the part that comes after the base, flips and goes after the equal sign. So it's kind of like these two switch places is one way to remember it. That's your answer to the question. So this one would be 3 to the 4th is equal to 81. Notice that these answers to the questions that you're getting are true. So these equations are true equations. 2 to the 5th does equal 32. 3 to the 4th does equal 81. But just because it's a true equation doesn't mean that you wrote it the right way. You want to make sure that you write it in the right order. So the base stays the base. Logs equal exponents. So this becomes the exponent. And then this number goes over here on the other side of the equal sign. This one would be 11 to the 0 power is equal to 1, which is also true. And then this one would be 25 raised up to the negative 1/2 power would equal positive 1/5. And so that's also a true equation. Questions 5 through 8 ask us to do the opposite. So these are given to us in exponential form, and we're being asked to rewrite them in logarithmic form. So we're going to introduce the word log in all of these. Remember that the base of the exponent part stays the base for your log, and logs equal exponents. So the 2 is going to end up being on the other side of the equal sign where the 36 is. This one would say log base 636 is equal to 2. 6 would be log base 12 of 1 is equal to 0. 7 would say log base 1/2 of 8 is equal to negative 3. And then lastly, this one would say log base 4 of 1 over 64 is equal to negative 3. The key with making sure that you're writing these in the right order is that whatever number is in the exponent to start ends up being on the other side of the equal sign, and that's because logs equal exponents. The next section of the review, so questions 9 through 16, ask us to evaluate each of these logarithmic expressions without using a calculator. So there will be a no calculator portion of the test. You want to make sure that you don't just try to plug these into a calculator and get the answer that way, because then you won't be prepared for that part of the test. Logs equal exponents. So this equation and all of the equations that follow are technically missing the part where it says equals x on all of them. If you wanted to add that part in, you'd be welcome to. This is saying 5 raised up to what exponent gives you 25 out as the answer. And so for this one, if you did want to write the equals x, you could put it there. It's asking you 5 to the x power equals 25, and so you're just trying to figure out what that exponent would be. And so the number that would make this be true would be the number 2. 2 is your answer for that question. For this one, you can put the equals x if that helps you. So 4 to the x power is equal to 64. So for this one, you're asking yourself, what do you raise a 4 up to get 64 as your answer? And so the answer for that one would be 3. 13 to what power gives you the number 1? And the answer for that one would be 0, because anything raised up to the 0 power is equal to 1. And so the rest of these continue. They start to get a little bit trickier here in a bit when they have fractions and negatives and things like that, but it's the same pattern. 9 raised up to what exponent gives you a 9, and so that would be the number 1. On 13, 4 raised up to what exponent would flip and give you 1 over 16. And so there's a couple of different ways that you can manipulate this. 4 squared would give you a 16, but that 16 would be in the top. This 16 is in the bottom, and so that's the reason that this answer would have to be negative. Anytime you're switching from a whole number to a fraction, or from a fraction to a whole number, it means that something had to flip, and so that's how you know that your exponent is going to be a negative number. And then same thing with this one. So 9 to what power would give you a 3? When you're answering question 14, the number's getting smaller, so it's not flipping. It's not that the 9 is becoming in the bottom of the fraction, but the number's getting smaller. The square root of 9 would equal 3, and so for this one, the exponent would have to be a 1/2, because an exponent of a half is the same thing as taking a square root of a number. On question number 15, they're saying you're raising a 3 up to some exponent and you're getting a negative number out as your answer to your question, and that's not possible. So for question 15, you can write no solution. You can also write the word undefined. So there's not a way to make that happen. It just doesn't work. And then lastly, question 16 is another one where it starts out as a whole number and then it finishes as a fraction. So 49 to the x power, that would give you 1/7. So two things are happening here. The 49 is flipping underneath, but then also something else is happening because the 49 is turning into a 7. Flipping it means the number would have to be negative. Making the number be smaller means that it would have to be a fraction exponent. And so for this one, the exponent that would be needed to make that be true would be the exponent -1/2. For the next section, questions 17 through 20 ask us to evaluate the logarithmic expression without using a calculator as well. So this would also be on the not calculator portion of the test. Log 100, notice that there's not a base written on the log. Anytime you see log without a base, it means it's the number 10. So this is asking you 10 raised up to what exponent would give you 100 out as the answer. And so the answer for that would be 2. You would square 10 to get 100 out as your answer. ln e is always equal to 1. That means that if you have ln e to the 4th, there's a couple different ways you can handle figuring out what this is. You know that ln e is always equal to 1. The 4 that's acting here on the e to the 4th power, I guess it would probably make more sense to do this. ln is the same as log base e. And so this is saying e to what power is the same thing as e to the 4th. And so the answer for that would be 4. On this one, you know that ln e is equal to 1. So this is going to turn into -5 times +1, which is going to give you -5 as your answer for that one for question number 20. Questions 21 and 22 are just calculator work. And the reason behind these questions is to help you remember that taking the log of a number and taking the natural log of a number give you different answers. The directions to the questions for 21 and 22 say to round your answer to the nearest thousandths. So you're going to round it to 3 decimal places. So you're just typing these into the calculator. When you type in log of 12 rounded to the nearest 3 decimal places for this one, you get 1.079. And then when you type in ln 12 into your calculator, rounded to the nearest decimal, you get 2.485. So these do work out to be different numbers. Remember, this one means log base 10, and then this one means log base e. So they are different from one another, and you do get different answers for these questions. So logs and ln's do the same thing in equations, but they don't mean the same thing when you're using them to evaluate expressions like this. For question 22, when I type in log of 1.25, I get 0.097. And then when I type this one into my calculator, I get 0.223. Any problems that involve evaluating expressions like this would not be on the no calculator portion of the test because you would need a calculator to solve these questions or to evaluate these expressions. For the next section of the review, questions 23 to 25 ask us to expand the logarithmic expression. And so we're going to follow the rules that we would use to expand it. It's usually helpful to do these in more than one step. Looking over here, this is a product, and I know that multiplication becomes addition. So this is going to turn into log base 2 of 5 plus log base 2 of x to the 3rd. There's a couple things that I want to check. Log base 2 of 5 doesn't work out to have an integer answer, so I'm not going to have to do anything more with this, but to expand this expression, I'm going to want to make the adjustment. There's one more thing that I can fix on the next one. So this 3 that's up in the exponent here, in an expanded expression, is going to come out front. So my final answer for this question is going to be log base 2 of 5 plus 3 log base 2 of x. And so that'll be my final answer for that question. In expanded form, all of the exponents will come out front and become coefficients. On 24, the question says ln, or natural log of the square root of a. It'll help me to do this question if I rewrite it, and instead of writing the square root, I'm going to write it as a 1/2 exponent. So in expanded form, this 1/2 exponent will flip out front. And so my answer for this question is going to be 1/2 ln. There wasn't much to expand on that one. And on 25, this is the last one where I'm expanding. Remember that division, so this is a quotient, becomes subtraction. There's 2 items in the denominator on this one, so there's going to be a -7 and a -y when I expand it. 3 bases means I'm going to have 3 logs when I write this one. So it'll be log base 6 of x, that's in the top, minus log base 6 of 7, because that's in the bottom. And then I'm doing some distributive property in my head in this final step, but it'll be minus log base 6 of y. And so that'll give you the final answer for that question. Whenever you're expanding an expression, so this one had 2 bases, so there were 2 logs in the answer. This one had 1 base, so there was 1 natural log in the answer. And then this one had 3 bases over here, so there were 3 logs in the answer. So those will always match up numbers-wise. For questions 26, 27, 28, and 29, you're not expanding the expression, you're condensing it. So notice how in 26 there's 2 log base 2's. I'm going to start by combining those together into 1. Subtraction becomes division. And so that's my first step, is writing both of these together as 1. Now, I do want to make sure I can simplify further if possible. I'm going to do this to the right. So this is going to become log base 2 of 4, because 28 divided by 7 would give you 4. So I can divide those 2 numbers. And then log base 2 of 4 has an answer to the question. There is an exponent that you can raise 2 up to turn it into a 4. And anytime that happens, you want to fully simplify that expression. So the answer to this question for question 26 would just be the number 2. The logs go away. And that only happens sometimes. That's one example of a time when it does happen. On question 27, I start by noticing that they're all addition, so it means it's all going to turn into multiplication. But before I put it back together, the 5 has to flip up here, and the 2 has to flip up here. So I'm going to have 2 steps for this question. It's going to be ln of x to the 5th plus ln of 3 plus ln of z squared. So I like to write it that way first. And now I'm going to do the combining part where I condense it back together. And so for this one, it's going to be ln written once. It's x to the 5th times 3 times z to the 2nd. And so I'm going to choose to write that in this format here. Use parentheses to show that it's all being ln'd. So 3x to the 5th, z to the 2nd. The order here technically doesn't matter, but it is usually written as coefficients or numbers first, and then it goes in alphabetical order after that. On question 28, I'm also condensing, and on question 29, I'm also condensing. So for this one, I have a number and then a second one that's being subtracted and then another one that's being subtracted. So when I write this down in condensed form, it's going to be log base 5. Remember, when you're condensing it, you're trying to only write this once. The 36 goes in the top. The 12 is being subtracted, so the 12 goes in the bottom. And then the x is being subtracted, so the x goes in the bottom. So that's my first step. This one has one additional step that I want to use to simplify it, because the x can't simplify, but the 36 and the 12 can both divide with each other. The 36 can divide by 12 and turns into a 3, and then the 12 can divide by 12 and turns into a 1. So this one is going to be log base 5, and then because it's a fraction, you want to use parentheses. So 3 over x, and that would be written in condensed and simplified form. On question 29, I notice that it's subtraction, so subtraction is going to become division. So for this one, I'll start by writing it as log base 3 of 97.2 divided by 1.2. So that's my first step. This is a fraction, so it should be written in parentheses. Then what you want to do is go to your calculator and divide 97.2 by 1.2. And so that turns into 81, so it turns into log base 3 of 81. And then anytime these are both numbers, you want to check and see if there's a number that makes that be true. So you're asking yourself, 3 raised up to what exponent gives you back 81 is the answer. And so the answer for that question, 3 raised up to the power of 4 would give you 81. And so that's how you determine that the answer to this question is just regular 4. So on this one, the log also drops because you could evaluate this exactly. This step is technically optional. You could just jump right from here to get to the answer to the question, because 3 to the 4th would give you 81. Questions 30, 31, 32, and 33 on the review give you information on the sheet that you need to have to be able to answer these questions. So it wants you to evaluate the logarithmic expressions, log base 3 of 6 divided by 5, but just being given the two pieces of information that are on your green sheet. So you're told what log base 3 of 5 is, and you're told what log base 3 of 6 is, and then that's the only information that you're given. So to answer this question, I'm going to choose to expand this logarithm first. Division becomes subtraction, and writing it like this helps me. I don't know what log base 3 of 6 divided 5 by is, but I know from the paper that log base 3 of 6 is equal to 1.631 because they told me that on the paper. And then I know that log base 3 of 5 is equal to 1.465 because, again, they told me that on the paper. And so I can substitute those values in because this is equal to this and this is equal to this. And then I can use my calculator to subtract these values. So 1.631 minus 1.465 will give you the answer for this question. And so for question 30, your answer is approximately, and it is rounded, it'd be 0.166. So that would be your answer there. A mistake that a lot of students make is they see division, so they want to just divide these two numbers, but you're actually subtracting them. So it's recommended that you expand the logarithm first. On question 31, it says log base 3 of 25, which isn't one of the facts that you're given. Log base 3 of 25 could be rewritten, though, because log base 3 of 25 could be rewritten as log base 3 of 5 times 5. And then multiplication becomes addition. So log base 3 of 5 plus log base 3 of 5. And log base 3 of 5 was one of the facts that you were given to start with. Log base 3 of 5 was 1.465. And so you're just adding it up with each other, or you could also think about it that you're multiplying it by 2. And so the answer for question 1, it's rounded because those initial values were rounded, but it would be 2.93 is what that would be equal to. You're always going to be able to magically work it out using the two pieces of information that they're giving you. So this next one for 32 says log base 3 of 30. Log base 3 of 30, I'm going to choose to write the number 30 as 6 times 5. And the reason why I pick those two numbers is because those are the two pieces of information that I was given to start with. Multiplication becomes addition. And so to find the answer to this question, I'm going to be taking log base 3 of 6, which was 1.631, and then log base 3 of 5, which was 1.465, and I'm going to be adding those numbers together. So just because this was multiplication doesn't mean you're timesing these numbers. You're adding them together. And so for this one, your approximate answer that you would get for question 32 is 3.096. And then lastly for this one here, for question 33, it says log base 3 of 1 over 6. So you want to think about different ways that you can get that as an answer to the question as well. Figuring out a way to write 1/6 using a 6 and a 5 is going to help you answer the question. You can't just do this as log base 3 of 1 minus log base 3 of 6 because they didn't give you log base 3 of 1. That wasn't one of the two pieces of information that was given to you here when you started. So you might think about what numbers could simplify to give you 1 over 6. That's a way to start the question. You could write log base 3 of 1 over 6 as log base 3 of 5 over 30 because 5 over 30 is going to reduce to give you 1 over 6, but then 5 over 30 would be written in this manner. So I know log base 3 of 5, I know log base 3 of 5, and I know log base 3 of 6, and so I'll be able to expand it using that. Those are 3 of the two pieces of information that I was given. So continuing over here, this will turn into log base 3 of 5 in the top, minus log base 3 of 5 in the bottom, minus log base 3 of 6 in the bottom. So this was in the top, so it went first. This was in the bottom, so it was subtraction, because division becomes subtraction. And then this one was in the bottom, so division becomes subtraction. So these two are going to end up canceling each other out. And it's fine to write it in that manner too. I'll still write it down though. So log base 3 of 5 minus log base 3 of 5 minus log base 3 of 6. And so these cancel. And so your answer for this one, for question number 33, your answer to the question is approximately, let's see, I'll write it down here, negative 1.631. And so that's how you would arrive at an answer for that question. When you're solving exponential equations that have numbers as bases, you know that you're going to use logs to solve this one. So I'll start by adding 2 to both sides. And so as soon as I get to the part where the base is all by itself and I'm sort of stuck and I'm not sure what to do to move on, you're going to log both sides. Taking the logarithm of both sides of this equation seems like it's making it more complicated, but it actually helps you because what it does is here, it lets this x flip out to the front. So my problem is going to become x log 4 equals log 9. And then to finish solving, to get the x all by itself, I would need to divide both sides by log 4. The directions for this question state that they want you to give the exact solution. So this would be the exact solution, the answer to that question. But then it also does indicate that it wants you to type it into your calculator to give the answer rounded to 3 decimal places. And so for this one, for question number 34, rounded to 3 decimal places, it's going to be 1.585. So you want to give all of your answers both ways like that one. You have to get the base all by itself. So for question 35, I need to start by dividing both sides by negative 3. That's going to give me 6 to the 8. X is equal to 8. When you get to the part where you have the base all by itself and it's kind of like you're not sure what to do, that's when you log both sides. And so the reason why you're taking the log of both sides is because you have to get this exponent out of the exponent, or get the x out of the exponent, so that's going to flip it out front. That's going to turn this one into x log 6 equals log 8. And then you're solving it, so to get the x all by itself, I'll divide both sides by log 6. And so my exact answer would be log 8 divided by log 6. And then because the directions to the question say they also want it rounded, go ahead and type those ones into your calculator as well. So for question 35, rounded to 3 decimal places, it's going to be 1.161. Question 36, notice that there's no number in front of the number 10. There's no number, like there was in the previous questions, there's no number that comes after it. This x and this negative 5 are both up in the exponent. And so when you're doing the work for this one, it just means that it's ready for you to log right away. So I'll take the log of both sides. When I take the log of both sides, the power property says that this x minus 5 can flip out front. So it's going to turn into x minus 5 log 10 is equal to log 3. Putting this in parentheses helps you accidentally keep from forgetting that these two things have to be considered together. So to get the x all by itself, I can't add the 5 to both sides yet. I'm going to divide both sides by log 10. And then I'm almost done. I can drop the parentheses now. To finish getting the x all by itself, I just need to add the 5 to both sides. When you write your final answer to this question, it's standard that the 5 would get written first, and then the log 3 and log 10 would come afterwards. Something that you want to notice about this problem is that anytime you see a log 10 is actually just equal to 1, because log 10 means log base 10 of 10. So right here, when I write my 5 first, and then I'm going to write my next part, log 10 is equal to 1. That actually means that if you had recognized that earlier, this is equal to 1, this is equal to 1, so you could have just omitted them from this part right here and gotten rid of them earlier. But even if you don't catch it until later, that's fine. So this one's going to give you just log 3. This would be your exact answer to the question. And then if you were going to round it, 5 plus log 3 would give you approximately 5.477. rounded to 3 decimal places. So again, if you noticed earlier that log 10 was going to be equal to 1, you could, as early as this step, you could just omit it from all those parts of the equation. It would actually be omitted here as well, and then you would get the same answer to the question. So either way, you're fine. That won't happen on the next one, because notice on this one, my base is 7. This question's also ready for me to log both sides, though. So I'll take the log of both sides. And then right here, it'll flip out front. Remember, when it flips out front, you want to put it in parentheses just for the time being. So I flip the exponent out front, and then I'll divide both sides by log 7. That'll make this come over here. And so this problem does have a few more steps that I need to do to finish. Let's see. 2x plus 5 is equal to log 11 divided by log 7. So I need to minus the 5 from both sides. And then to finish the question, I would need to divide this side by 2, and I would also need to divide this side by 2. And then stylistically, when you're writing your answer to this question, the 1/2 is going to get pulled out front. And so this would be my exact answer to the question. These could get written in the other order if you wanted them to, but writing them this way is fine. When you type this into your calculator to get your exact answer to the question, or to get your approximate answer to the question, this one works out to be approximately 1.884. And then last but not least, on this one, notice that the 8's already all by itself, which means it's ready for me to log both sides. And then the exponent will flip out front. So as I continue to finish solving this problem, I'll divide both sides by log 8. So I'll have x over 3 is equal to log 13 divided by log 8. And then to finish the question for this one, I'm trying to get the x all by itself. So I'll times both sides by 3. So I'll have x equals 3 log 13 divided by log 8, like this. And then you could also write the 3 up in the top next to the log 13. That would also be considered as a correct answer to the question. And then when you type this into your calculator, you'll get approximately, rounded to 3 decimal places, it'll be 3.700 when you round it in your calculator. A key to getting these questions right is making sure that you only touch your calculator once, and you're only touching your calculator once at the very end to give the decimal approximation to the answer to the question. The last 5 problems on the review give you exponential equations to solve, but they're just a little bit different because this one's the base isn't a number, the base is the letter E, and so that's how you know you're going to use ln when you solve these. So on this one, I'm not going to log both sides. I'm going to ln both sides. Taking the properties into consideration, though, lets you flip that out front. And so I'm going to have x ln E is equal to ln, oops, this should be an 8. ln 8. And then to finish this question, you could divide both sides by ln E, or you could remember that ln E is always equal to 1, so this just disappears from the problem. And so for this one, to write the answer out exactly, it would be x equals ln 8. So that would be the answer to question number 39 written out exactly, and then rounded to 3 decimal places, it's going to be 2.079. The next one has a step that I have to do first, though. On this one, I have to start by dividing both sides by -6 because I'm trying to get rid of this coefficient, this number that's out front. That's going to give me e to the x is equal to 9. And then once you get to the part where you just have the base, in this problem it's going to be the letter e, and then it's raised up to the exponent, this is where you ln both sides. The exponent flips out front. And then in the final step on this one, you could divide both sides by ln e, or you could remember that ln e is equal to 1, so it's just going to go away. So for question 40, you get x is equal to ln 9, which rounded to 3 decimal places gives you 2.197. On question 41, there's 2 things that I have to start by fixing. So I'll start by adding the 4 to both sides. That's going to give me 2e to the x is equal to 20. And then I'll divide both sides by 2. And so that'll give me e to the x is equal to 10. So I have to do manipulations to the equation to get the e all by myself. Once the e is all by itself, then I'm good to ln both sides. I'll use the power property to flip that x out front so it turns into x ln e is equal to ln 10. And then remember that ln e is always equal to 1. So x will be equal to ln 10, which written out to a decimal would be 2.303 rounded to 3 decimal places. On question 42, I need to start by dividing both sides by 5. And then now I have the base all by itself. These are both stuck up in the exponent, and so to get them out of the exponent, I'm going to ln both sides. The 3 to the x flips out front. And so this one's going to turn into 3x ln e is equal to ln 7. Remember from before that ln e, this part right here just turns into a 1, so it's like it goes away. And then to get the x all by itself, I'll need to divide both sides by 3. So written out exactly, question 42 is going to say either x equals ln 7 over 3, or you could choose to write it as 1/3 ln 7. Those would be the same thing. And then either way that you choose to write it, when you type it into your calculator, you're going to get 0.649, and that would be the answer rounded to 3 decimal places. You don't have to write this both ways, but it is helpful for you to recognize that both of these ways of writing the answer to the question do result in the same answer. And then last but not least, question number 43. It's ready for me to ln right away. Remember, my exponent flips out front. And then it's helpful to recognize here too that ln e turns into 1, so that part just goes away. So I'm going to have 4x minus 5, no more parentheses needed, is equal to ln 32. And so I've just got 2 more things left to do to get this one in the right format. I would add the 5 to both sides. So I'm going to have 4x equals 5 plus ln 32. Remember, it's stylistic, but this number usually goes in front of that part. And then to finish it, I would divide both sides by 4. So you could write it like this. Sometimes you'll see it written where the 1/4 gets pulled out front. And so that's the same thing. Doesn't matter which way you want to write it. And then you would type this all into your calculator and rounded to 3 decimal points for this one, you would get 2.116. And that would be your final answer to the question. As a bonus for watching the video, we just wanted to remind you that for questions 34 to 43, so the whole back side of the review where you're going through and solving, you can check every single one of these answers to make sure that you're getting it right on the test. So let's use an example. For question number 34, the problem started out as 4 to the x minus 2 is equal to 7, and we did all the work for this question and rounded to 3 decimal places. We got that the answer to the question was x equals 1.585. So to check this, you can take the 1.585 that you got for the x, and you can plug it in here into the exponent. So in your calculator, you're going to type in 4 to the 1.585 minus 2, and then that's going to give you a number that's really close to 7. One thing that you want to remember, though, is that that is a rounded answer, and so when you type it into your calculator, I'm doing it right here, so I did 1.585, and then I did subtracted by 2. When I hit enter, it's always going to be a little bit off, so it's not going to be the exact answer to the question, but it's going to be so close to the number 7 that you're going to know that you did the answer right. And so does this equal 7? It does. And so that's how we know that we got the right answer to this question. This will work for any problems that you want to check. I'm just going to check a couple with you today. So for number 38, it said 8 to the x divided by 3 is equal to 13. And we already did all the work for this question. Rounded to 3 decimal points, we got x was equal to approximately 3.700. So again, on the test, if you wanted to check it, you would take this number, you would plug it in up here. So you'd be typing in 8 to the 3.700 divided by 3, and you're checking to make sure that that equals just about 13. So again, on your calculators, you're just typing it in, It only takes a second to type it in, but it's helpful because you can know if you're getting these questions right. So for this one, I typed it in, and it doesn't give me exactly 13, but it gives me practically 13. The only reason why it's not equal to exactly 13 is because it was rounded. And so you can check and make sure you got the answer to that question right. If you plug a number in correctly, and if you don't get the right answer to the question, that's how you know that the answer didn't work out to be the right answer. So if I plugged a number in, like if I plugged in a different number here because I got the question wrong, and if I did this math, and if I didn't get 13 as my answer, then I would know that I had made a mistake when I was solving it. Let's see, I'll do question 41 also. It works for any of the problems. So 41 started out as 2e to the x minus 4 is equal to 16. And so we did the math for this one already, and we got that the answer was approximately 2.303. And so to check this one, you can also take this value, and you can also plug it in. So in your calculators, you're going to type in 2e to the 2.303 minus 4, and you're going to check and make sure that that gives you just about 16. And so you'll type it into your calculator just like that. The E button on your calculator that gives you the exponent is this E button over here that's above the ln key. So 2e to the 2.303 minus 4, and when I type that into my calculator, I get, a smidge more than 16, but that's how I know that I get the answer to the question right. So anytime you're solving, you can do this math and you can check your answer for any of those questions. That would be a helpful hint for you to use on the test.